So this is like my regulars, so welcome back to my regulars. Thank you for being here as always, and you guys make this time a lot easier for me because of your uh, participation, so thank you for that. So the plan today is first to finish Lab 12. We left 5 functions that weren't written, and then we'll go over to Project 3, and I'm going to show you I'm going to take one of the ideas from Lab 12 over to Project 3 as part of what it is that I do. All right, so that's the plan. Okay, so Lab 5. So what we did at Lab 5, Lab 12, what we did on Tuesday was the strings of length function, the strings longer than function, the strings shorter than function, the strings beginning with function, and then the contains string function. So we've got these 5 left. The get unique is easily the hardest one, so we're going to do that last. Um, these other 4 aren't hard, and 2 of them kind of use the other 2 as a part of their work. So I'm going to start with length of shortest. So this is an algorithm I'm about to show you, and we're going to repeat this algorithm, the approach to solving this problem, in the next function, and then I'm also going to show you how to use the same idea, the same algorithm basically, in the third project. So we notice here we're supposed to return a length of a string, so that will be an integer. So what this is supposed to do is if we have a list that looks like this, this function is supposed to find the shortest string and return its length. In this case, the shortest string is apple and its length is 5, so the function should return 5 on that data. So the result is going to be an integer that we return at the end, and then we have to compute it. So here's the way I like to solve this problem. It's actually, well, not everyone would do it this way in their head, but in my mind, this is kind of how you would explain, say, to a child how to solve this problem. So what you might say to a child is, I want you to find the length of the shortest string in this list of words, the shortest word by count of characters. And the way you might tell them to do that is, well, let's start by assuming that the first word, and in this case, the first word comes from that list, and it's at index 0. So let's just assume that the length of the first word is the shortest. So I'm going to take the length of the first word, the string at index 0. I'm going to take that length, and I'm going to assume that it's the shortest one. Then I'm going to write a counting loop. This one is a slightly different counting loop because now I'm going to say, all right, now assuming that the first word is the shortest, look through the rest of the words and see if you can find something that's shorter. So when I write this counting loop, I am not going to start at 0 because I already considered position 0. So I'm going to start at 1, which is where the rest of the list starts from. I'm still going to do I less than the length of the list. I'm still going to do I plus plus. But the trick is I've already sort of assumed that the first string, the string at index 0, is the shortest by its length. And now I'm going to use a counting loop to look through the rest of them, starting at position 1. What I'm looking for is if the length of one of these other strings is less than what I thought was the shortest, well, that must be the shortest. So notice I'm not using colon equals here because I'm just overwriting a variable. So if the length of that next string in the list is shorter than the one that I thought was the shortest, well, I guess that one is the shortest now. So that one becomes the shortest. And if I do that, I don't know why I have I don't know why I have result. I don't need result. Let's get rid of result. Because what I'm really looking to do is return the shortest. This thing right here. So assume the first one is the shortest by its length, and then look through the rest of them, starting at the next index over, going all the way through to the end, moving forward one at a time. And then I look at the length of each of them, compare that with what I thought was the shortest, and replace the shortest with that length whenever I find something shorter, and that should give me the shortest. I'm going to do the test here. So I'm going to, hopefully I have the screen set up correctly. I do. So let's go test that. I'm going to do -v to get the verbose test so I can see the passes and the fails. And I'm looking to see if length of shortest passes. It does. Okay, so I'm happy with that. So assume the first is what you're looking for, and then use a counting loop to look through the rest of them to see if you can find something better. So we're going to use the same approach to length of longest. We're going to assume that the longest one is the first one. Then we're going to use a counting loop to look through the rest of them, meaning starting at index 1, the next one over from 0. Go through the entire rest of the length of the list one at a time. If the length of the one I'm getting in the loop is longer than, greater than, the longest one that I thought was longest, well, I'll just replace the longest with that. And then once the loop is done, I can return the longest. I have now found the longest string. So same algorithm. Assume the first one is the one that you want, and then look through the rest of them to see if you can find something better. In this case, better is longer, whereas in the earlier one, the better was shorter. And then at the end, you should be able to return what you now know is the longest one. I'm gonna go test -v again, so I can see all the passes and the fails. Length of longest passes. So still doing good. Okay, so list of shortest. So I kind of think of this as passing the buck or lazy programming. But what I've done in your lab is I've set up a situation where you actually have functions that already solve parts of your problem for you. So the list of shortest. So returns a slice containing, so this time we're back to returning a slice. Returns a slice containing all strings in a list that are the same length as the shortest string. So if I had a list that was if I had that list, well, the shortest is 2 characters, so the list of shortest should be no and up. That's what the function should give back if it were given this list of strings. It would find that the shortest string is 2 characters, and then it would return all the strings that have that character. Alright, so how do we go about doing that? We are going to need results this time. And the results we want to create this time are a string slice, which we'll return. Okay, so how do we get the list of shortest out of here? Well, the first thing we need to know is what is the shortest. And happily, we have a function that, if you give it a list, will return for you how long the shortest one is. So I'm going to do that. Shortest equals length of shortest of, oh, it's already called list, of my list, so it's perfect. So I'm going to use the function we just worked on to figure out how long is the shortest one. Then, in fact, So now what I want is a list of all the, I want to take from this list everything that's of this length. And in fact, I already have a function that does that too. Strings of length. So if I give this function a list and the length that I want, it will return a slice for me, which is the best thing that's ever happened. Because I barely have to do any work here. So if I have the shortest, I can say my results, and I don't even need this anymore because another function is going to build it for me. My results can be, what is it? Strings longer. Okay, strings of length. I give it a list and then the desired length I want. Now in this case, the desired length is everybody who's that short. And I'm done. So I use one function to figure out what the length of the shortest is. I use another function to give me as my results all the strings that are of that length. I don't even have to do any new work. I just have to assemble function calls. So we do -v again. We will look for list of shortest, which I am now passing. List of longest. It's going to look pretty similar. So I can get the longest by saying length of longest, and I give it a list, and that's the same list. And then I can make my results come from strings of length again. So same list. Now the length this time is everybody who's that length of the longest one, and then I can return those results. So again, I didn't have to do any actual new processing work. I just had to take advantage of the fact that I have functions. If I can get the length of the longest, which I can, then I can get all the strings of that length from my list. Pretty nice. Now I'll test with -v to see if I pass. So passing. So this is nothing to feel guilty about. This is something to feel happy and pleased with yourself about. If you can find a way to solve a new problem by reusing old parts, that's good. Okay, now let's scroll back up and do the hard one. It's not super hard, but it is the hardest one. So get unique. So here's what this function's job is. Let's say you have let's say you have a list of strings that looks like this. Get unique, what I mean by that is give me every word in here, but don't repeat any word. So for example, apple is repeated, so my result should just have apple once. Banana is here, but it's also repeated, so I just want to get that once. And then cherry is here, but it's not repeated, so it also goes in there once. So my result in this case should be all the words that are in the original list without the repetitions on there. That's what I want this function to do. Okay, this one is the most challenging one. It's supposed to build up a slice of string, return those results. Okay, so here's the trick here. You have to imagine, in fact, let me bring up my camera and draw you a picture real quick of what's going on. I don't know if this will be helpful to you, but so you can see my thought process, maybe it helps. Okay, so I'm just going to quickly show you my thought process here. You have a list. And it has, we don't know what in it, but let's just pretend like it has apple, banana,
apple, cherry, banana, apple. Sorry about the curve, but it's far away from my arm. So here's our list if we're pretending like it. And then I have results. And initially, my results is going to be empty because var results string on the code is empty. So the whole point here is to first write a loop to go through all these strings. So in other words, read each one of these to start. All right, so let's do that. Let me move my my drawing over. Someone may have to remind me to move this out of the way later. But let's start with that. I'm going to use a range loop. I already know I don't need the index, by the way. So I will say for each string s that I get as I range over that list. So as I do that, s is going to be apple, and then banana, and then apple, and then cherry, and then banana, and then apple. So the trick is, as I get a new s, I want to look over at my results and see if I've already written that word down. So does my results list contain that word yet? I have a function for this. It's called contain string. If I give it a list and a string that I'm looking for, it will tell me if I've already written that string down. So if it doesn't, that's what I'm really interested in. This exclamation point means not. So which list am I talking about? It's actually my results. So I'm going to look in my results to see if it doesn't yet contain that string s that I got from the original list. If it doesn't, then I'm going to add it to my results. So the way this would work in the drawing is that I would get this s, and then I would say, does my results not contain that? It doesn't, so I'm going to write it down. And then the range loop is going to pick up banana, and I'm going to say, does it not contain that? And the answer is going to be it doesn't. So I'll write that one down. And by writing it down, I mean appends, right? The results appends. All right, so now the range loop will pick up this apple, and it's going to say, does it not contain, oh wait, it contains apple, so I'll skip that one. The range loop will pick up cherry as s. Is it not here? It isn't here, so I will append it. Banana comes next. Is it not here? Nope, it's here, so I don't append it. And then the last one it hits is apple as s. And I look over here and, oh, nope, it contains it. So I end up with results that look like this. That's the unique words from this list, the unduplicated words. So that's sort of an explanation of the algorithm that I'm using. So it's actually very little code. It's just the one that's the most difficult, I think, to understand how to do it. So this is a very computer sciencey thing, which is good because that's what we want to be doing in here. So I'm going to do it. First, I'm going to go with the -v just to see if get unique passed, which it did. So now if I take the -v off, then if I fail anything, it will show me, and if I don't fail anything, it will just say pass. So I pass, so all the functions work. So that is lab 12. All right, and we're doing good on time. Hopefully I'm not going too fast for anybody. But of course it's on video, so you can always peek at the video later if you missed any part of the lab. We just finished the last 5 functions of lab 12. Now, I'm going to leave this file open because I'm going to come back to this, assume the first one is the one I want, and then look for something better algorithm. I'm going to use that here in a second. So let me open where we left off on the project, which is this stuff, right? Yeah, okay, so let me move around a little bit here. And what I mean by that is just get my folder in the right place. Okay, so let me see where we left off. Go run. edit which cell, cell 1. I just did a quick example just to see if it actually got in there, and it did, so that's good. Okay, so now we got to add some functionality. I'm going to fetch the pictures. Okay, so I've brought up the picture. Because we want to sort of enhance some things. And we're going to like work on maybe getting a minimum. Okay, so the way this is set up, each of these, so that's row 1, which is a slice, row 2 is a slice, row 3 is a slice. I do not have all these slices in my project right now. I've only got 2. Yours needs 5. Row 4 is a slice, row 5 is a slice. Each of these has 5 elements in it, and we looked at displaying everything up to the vertical bar. Now I'm worried you can't see. Oh, yeah, because I need to put the mouse over here. We worked on everything up to displaying the vertical bar. Go back. But we don't have these parts yet. So what's going on over here is a calculated value. So this 44.42 is the result of computing the averages of all the values on this row. And this 0.53 is the result of locating the minimum value in this row. And then 1105 is computing the sum of all the values on row 3. 2.90 is the maximum value on row 4. 6.70 is the minimum value on row 5. So every row has its 5 data points, but it also has a calculated value, and it has a label telling you what calculation it performed. So what we want to do is see if we can get one of these calculations in there. First thing I'm going to do, though, is update the display to show calculations. Before I do that, let me go back a step and just show you this picture. So what this picture shows you is that when the program first starts, the calculations to be performed are not known. They're just empty. And the calculated values are all 0. So that's important to make note of. Okay, so how do we make that stuff work? Okay, so we're going to end up with 5 rows up here. Hopefully you can see my code again. I believe you can. So there's going to be 5 total rows, but there's also going to be a calculations slice, which will be the calculated values, 1 for each row. So these are the calculations for the rows. You can sort of think of these as going down as a column. But since there's 5 rows, there's going to be 5 calculations. And we're also going to do operations. That's the labels that tell us if it's the average or the minimum or the sum. So we're going to make a slice for that, but those are just strings. Those are little tags that tell us, but we'll also be able to use them in code. So the thing you have to, we've done this before actually. This is using a slice in parallel in a way. So what you have to imagine is that, I'm going to put notes here and then erase them because I don't want the trash in here. So calculations, position 0 is the row 1 calculated value. Calculations at 1 is the row 2 calculated value, and so on until you get to calculations at 4, which is the row 5 calculated value. So that's the meaning of calculations. The meaning of operations is very similar. So operations at 0, that's the tag. That's the row 1 operation tag. So for example, like average or minimum or maximum or sum. I think that was all the operations. Operations at 1 is the row 2 operation tag, and so on to get down to operations index 4, which is the row 5 operation tag. So these are a little bit different. You just have to get it straight in your head. The rows go across. The calculations, in a way, they go down. So calculation 0, calculation 1, whereas row 1, all of its data goes across. That's how those are designed to work. I'll leave those notes there for this iteration. Okay, so let me bring up the browser and then present our problem. And I'm going to go back to this other picture. So our problem in the display to solve is that we need to show the calculation for row 1 here and the tag for row 1, which means that our display function has to be updated. So when you're writing these functions like display row, don't just throw anything in the parameters. Think about what it is that you need to be able to do the job. So what does it mean? What do I need to know to display a row? I'm going to bring the browser back. What I need to display a row is the row number. I need the row data. I need the calculation value for that one row. That's one value. And I need the tag for that one row, which is also one value. So the calculation and the operation, or the tag, I need those to do the display, which means I have to update my display function so that I have them. So display row, I have the row number, took care of that. I have the row itself, that's all the data. I also need the calculated value. I'm just going to call that calc. That is a float 64. It's not a slice of calcs. It's one calculated value because one row has one calculated value. And then I have a tag, which I'm going to call the op, like for operation. That's a string, not a slice of string, because a row only has one operation tag. It has one calculated value that's a float 64. It has one operation, which is a string. It does have a whole slice of fields, the data part, and then it has one row number. Okay, so hopefully that part makes sense. And now let's finish the function. We have this bar here, which we saw in the picture. I'm going to space that over a couple. After the bar, we have, am I going to put, I might put a couple of spaces in there too, just to make it easier to read. So after the bar, I'll show you one more time. After the bar, we have the calculated value and then some parentheses with the tag inside of it. So after the bar, we have a float. That's the calculated value. Like I did the other floats, I'm going to make that 10 wide and to 2 decimal places. And then I have a space, and then I have some parentheses, and I have a tag or a string inside of there. The %f part, that's the calc from the parameters. And the %s part is the op, the operation tag. So that's that function. But look how tiny that is for that much information. So that's pleasing. You're going to see errors come up because of the way I have Adam set up. Don't worry about it. They're not really errors. Okay. So hopefully everyone sees that's all the information that's being displayed when I display one row. The row number, which has to be provided, the row itself, which has to be provided, the calculated value, which has to be provided, and the operation tag, which has to be provided. So if I'm to display a row, I have to provide 1, 2, 3, 4 pieces of information. So now I'm going to scroll down to main here where I'm doing my little experiment. So to display a row, I need the row number. And row 1, I want the number 1 in front of it because otherwise it would look like I've got something wrong with me. The row itself. Then I have a calculated value. I happen to remember that calculations at 0 has the calculated value for row 1 in it because I made a note to myself about that. And I happen to know that operations at 0 is the tag for row 1. Same for displaying row 2. So the number I want to show at row 2 is a 2. The data is in the row 2 slice. The calculated value is at index 1 of the calculation slice. The tag is at index 1 of the operation slice. Hopefully that makes sense. I need to, everywhere where I do display row, I need to make sure that I'm doing that. This, by the way, this is not how you should do main. I'm just showing you, giving you building blocks. See this note here? It says display all rows, calculated values, operations. It doesn't actually say to do that again. The only reason I'm doing that again is so I can see if editing works. And so you're going to see me do this a couple times. So you're going to have to think about how to organize this part of the program. But the displays technically should only happen once. Okay, so let me fix these two display rows because this is row 1, so that's calculations at index 0, and the tag is at operations at index 0. Row 2, calculations at index 0, operations at index 0. So the only change I've really made so far is I've updated the display in the hopes that it's going to look like what that picture on the project page looks like. I still have the edit test in here, just to see if when I edit it, does it still look the same after. So let's go run that. Hopefully I fixed the screen so you can see it. Yeah, you can. Okay. So let's run it. Okay, so if you can see this now, there's the calculated value and the empty operations tag, which is what it should be when I first make an empty slice, and then the calculated value for row 2 and the empty tag as it should be to start. So that's pretty neat. I'll go ahead and edit cell 1. So the display, when it circles, when it shows up after the edit, still everything's just fine. Okay. Ooh, good catch. Thank you. Everybody listened to good catch. I did row 2 on the wrong place. Thank you, because that was going to be upsetting here in just 2 or 3 minutes after we changed some stuff. Good catch. Okay. Let's go ahead and, yeah, I can leave that one there. So this is sort of a manual test. This is not how the actual program should work. But what I'm going to do for starters is I'm gonna edit row 1 5 times, and the reason I'm doing that is, one, to make sure that all the values get in the right places. So I have to make sure as the user that I say cell 1, cell 2, cell 3, cell 4, and cell 5. But then I'm going to do this display, and then I'm going to try some other stuff. Is that what I want? Yeah, let's do it that way. In fact, I might give you more than 2 functions. We'll see. We'll see how far we get. Yeah, let's do that. Edit all 5. Okay, so the reason I have 5 of those is because I'm gonna carefully, when I run the program, select cell 1, cell 2, cell 3, cell 4, cell 5. But the reason I'm doing that is because I want to add I want to find minimum value on row 1. So I'm going to add this new function. Um, in fact, I'm going to do that after my little editing test. So again, this is not how the program should really be set up. I'm just trying to give you help with the building blocks. So I'm doing this just as a test, a manual edit. So now I'm going to write this function that's meant to find the minimum value of row 1. And when I do that, I want to return a value that I store in my calculations. In fact, let's do 2 steps. While we're at it, let's do some building blocks here. So anyway, in the real program, a user is going to say, I would like to see the minimum value. Which row? Row 1, that kind of thing. So we're going to write a function that is going to find the minimum value of row 1, return that minimum value, and then I'm going to store it in the calculation slice. Hopefully everyone understands why it's calculations at index 0. That's not arbitrary. It might be hard to answer in chat, but if you can answer in chat, I'll let you do that. Why is, if I were to find the minimum value of row 1, why am I putting that in calculations at index 0? If you can't figure out a way to answer that in chat, it's a little awkward, don't worry about it. But if you can, have at it. Okay, so the reason why, and hopefully I'll come back just in case someone comes up with it, but when I do calculations like finding the minimum value, those results need to go into my calculations slice. So let's go work on this function, find the minimum value of a slice of floats. Edit row, display row. I'll just add that right here. It's going to get to be a lot. Find minimum value of some row of floats. What I will be returning is the float that is the minimum value from that slice of floats. So the reason why this doesn't say row 1 or row 2 or row 3 or anything like that is because I want to be able to take any of the rows and find the minimum value. Not just a single instance, but I want to be able to just say whatever row I want right now, I can send it in here and it's going to give me the minimum value. Okay, so here's where we're going to refer back to an algorithm that we did on the 12th lab. And the algorithm was, we assumed that the first one is the one that we want. So we're going to assume that the smallest value in the row is the first value in the row. So remember, just like we did the shortest string or then the longest string, now if we're trying to find the smallest float in a slice of floats, well, let's just assume that the first one at index 0 of that row is the minimum value. Then we look through the rest of them, which means a counting loop starting at the second one, the next one over, I less than the length of that row, so the whole rest of the row, I plus plus. And then we're looking for, in this case, a value that is less than the minimum that we think it is. So if we find an element that has a smaller value than what we currently think is the minimum, well, then that becomes the minimum. Same algorithm. If you'll go back in at lab 12 and look, assume the first one is the one you want, then look through the rest of them and see if you can prove yourself wrong. Once we get done with that loop, we should have our minimum that we can return. Okay, so this thing is ready for a run. We're going to display everything in its start state, which is all zeros and empty strings. I'm going to go through and I'm going to manually edit each cell of row 1, keeping track of which is the smallest value I type in. Then I'm going to have my function compute the minimum just of row 1, and then I'm going to redisplay, because what I should see down at the end of the row is the computed minimum value. That's what I ought to see, if I'm careful about it. Okay, so I'm just going to edit I'm going to mix up the values a little bit. So I'm going to put 2.2 first. I'm going to edit cell 2 and put 5.5. Cell 3, I'll put 1.1. Cell 4, 3.3. And cell 5, I'll put 4.4. So when I hit enter, it's going to immediately try to compute the minimum value of this row 1 that I just typed all those numbers into. If it works, then the calculated value down at the end is going to be 1.10, because I'm placing it to 2 decimal places. The tag will be empty. So there's the 1.10, so I correctly computed the minimum value. Okay. So, yeah, we're doing okay on time. Hopefully this isn't too much to take in one day. Just a reminder, though, that what I'm doing in main is not what you should do in main. What I'm doing in main is just trying some things out. You're going to have to set this up as a program that runs and has a menu and asks the user some questions, things like that. So you're going to need to work out how to make the flow of the program work. But we do now have the ability to edit. If we know which row, then we can edit a cell in that row. If we know what calculation to perform, we can compute a calculation, and then the display is picking things up. So the last thing I'm going to do here is I'm going to say oh, that's a clever idea. Yeah, you could use sort and then pull it off. As long as you're careful to not wreck the original data. That's a cool idea. Okay. Baby Doll brings up a good point, though. I'm not these aren't the rules that I'm showing you in terms of how to do it. There's just a way to do it, and you may find ways that you find more satisfying or more interesting, or that you just sort of discover from your own exploration and go for it. That can be very satisfying. Okay, so I am going to write one more function here, but it's going to be incomplete. Just a warning. I'll put a note in it, but it's going to be incomplete. Select operation on, it doesn't really matter. I don't really need the row to pick an operation. I just need to know where it goes. But it would be kind of cool to send in which row number we're talking about and what presently the operation is. So we're going to write another function called select operation that asks the user, what are the available operations would you like to use on row 1. So I'll show you how that looks when we build it. So this will be our last one for today, and I may not complete it. All right, select operation. I'm going to give it the row number just to make the output look nice, and I'm going to give it the current operation just to make the output look nice. Select operation. I'm going to put that right here. Doesn't really matter. Select operation. I'm giving it a row number, which is an integer, and an operation, which is a string. and I'm going to be returning a string representing the selected operation. Okay, so this will be a little menu basically. So they're gonna, I usually use numbers because if you let people type too much stuff, they're gonna make mistakes. So I'm gonna say choice, which is an int, and then I'm gonna show them the choices. So here's a little menu for them to look at. The sum, I think that was everything that I had. It's nice, by the way, to let people change their mind. So I'm going to put an option 0 and just says cancel. So if they said, you know what, I don't want to do anything, I'll just do that and give them that choice. So then the prompt is going to look like, I'm going to move this down here. The prompt. So the reason why I have row number and op here is to make the prompt look nice. So select an operation for row number %d current s. So it'll say like current AVG or something like that. It's going to show them what they currently have as an operation. I like it better as is. Okay. And then that will include the row number. It's going to run off to the side. So I'm going to drop it down to the next line. The row number and the op. So the row number and op are only there to make this look cool. They don't do anything. It just, I think it's kind of cool for me to say, hey, select an operation for row number 1. That's what you wanted, right? And then currently you're doing average or min or whatever. That way they're reminded of, what was I doing on row 1 again? I can't remember. Oh yeah, I was doing minimum. That kind of thing. That's all those do, is just make that prompt look cool. Take their choice, and then I will do some logic on it. I'll use a switch here just for fun. So the whole purpose of this thing is to return the tag. So if they choose 1, I'm going to return the shortened tag. That's how I like to do it. If you want to spell it out, you can. It'll probably fit, but that should be enough. If they select 2, the tag they're going to get is min. If they select 3, the tag they're going to get is max. If they select 4, the tag they're going to get is the sum. If they select 0, the tag they're going to get is the one that they already used. So I'll just return the same one that I got as what they're currently using. And anything else, I'll just return the original one also. So if they cancel or if they screw up, they're just going to keep their current operation tag. Hopefully. So there's that select operation. That's one of the bigger ones in terms of the number of lines to do it. But let's see what that looks like. Okay, so now I have to edit them all, which is a pain in my rear. I'm just going to this time say 1.1, cell 2, 2.2, cell 3, 3.3, cell 4, 4, cell 5, 5. Here's my little select operations. It's not doing anything yet, but since I am computing the minimum, I will go ahead and pick that one. And now my output is actually tagged because I actually changed the operations. there's more logic to insert there, but I wanted to sort of try to help you push forward on getting more of these pieces. So that function, you don't have to use it in that form. That's just one way that you might do that. But did you notice where it said select an operation for a 1, current is nothing. I wonder if I should have something other than nothing. Yeah, that's fine. That's fine. Current is, it doesn't know. Because that's empty to start. So there's work to do here in tying these together. So as an example, we may move this around, but just get you thinking about it. So if operations at 0 is minimum, then what that tells me is that I need to find the minimum value of row 1 for its calculation. This should be a function, but I don't know if that makes any sense. Now I know that it is because I would just pick it, but that's kind of how this needs to be used. So if you know the tags, that can tell you which of the functions to apply to calculate values for different rows. So the different tags are AVG, min, max, and sum, which means that you're going to have to do a find minimum value, find maximum value, compute sum, compute average, or whatever you do, whatever you want to call those things. Probably this I will refactor, meaning I will make updates and improvements to it next week. I don't want to take all your fun away, which I've already started to do quite a bit of taking your fun away. One thing I won't do, though, is assemble all these bits and pieces for you. So trying to give you the major parts and then examples. So if you know how to do find minimum value, hopefully then you can figure out how to do the other required calculations. And then you have some work to do in the main section with the menu and some other work that has to be done. But hopefully those things helped. 253, so that's it for what I got today. And I'll sit here and answer questions if you have them. Yeah, totally. Totally do that. We have in this class we have some people who have been doing really nice work and contributing on Discord, and Baby Doll's one of them, who's answered almost all, pretty much all the questions I think you've handled at this point. So yeah, please use the Discord. She's there to help, and she's been very active at helping people out. So I appreciate that, and hopefully you guys do as well. But take advantage of that. It's feels good to help people, and it's also a really good way to improve one's own understanding, is to try to sort of help other people through the things they find challenging. Okay, so let's do a file reading thing by request. So I'm gonna show you where I'm getting this stuff. So let me bring up my let me bring up the browser and show you where I'm getting this stuff from. So if you do Golang IOUtil, that's what we want to use. There's going to be some weird looking stuff in here at first. But we're going to do this read file thing. Which isn't super helpful just yet, but let's go from there. Yeah, and then we'll work our way up. So the thing to do, the first thing to do is make a file to play with. So I'm just going to do one of my, apple, banana, cherry, orange, strawberry, and then I'm just going to save that as let me put this in lecture notes and make a folder for this. I'll just call this input.txt. Input.txt. So I made a file called input.txt. I made a folder to separate these things out. And it just has some words in it. And we'll start from there and then we'll kind of see how we can match this to your need. But the first thing is let's just read some stuff in. So make a program for this. Gonna need IOUtil. Call this April23.go for mine. Okay, so, and then let's just make a main and let's just, so the important thing here is that, oh, you're not gonna be able to see that. Make sure that your folder has input.txt, oops. Okay, so make sure that your folder, let me close this and just, so this is my folder, has these two files in it. This will work a little bit better if those are just together there in the same place. And then we reopen my my editor. Okay, so input is just words for now, and then April 23 is the code. So the way I have Atom set up, it deletes the imports unless they're being used. So you'll see the imports appear, and I'll point that out to you. Okay, so we're just going to start with the so this is the most basic thing, and we haven't talked about this kind of function just a whole lot, but this will just read the entire contents of the file. And what you get is two things back. You get the file's data all in one sort of giant string, and you get this sort of error tag that tells you if there was a problem. And I'll create the problem just so you know why that's there. For now, we're going to ignore that. No, let's not ignore it. Let's do it the right way. So what you look for on that error is a nil error. And a nil error means that there weren't any errors in the process of opening and reading the file. And then what we're going to do for starters is just say file contents. And then %s. And then we'll just print the whole file data just to see if it came in. And then you'll notice up here that my atom now has added 2 imports. Okay, so what should happen when we run this program is it should open the file, it should read its contents, there should be no error, and it should print out the contents of the file. So there's the contents of the file. And notice that it's hard to see, but the new lines, the line breaks in the file actually came through, which is why they're all on separate lines, is because they're on separate lines in the file, so they read in that way. Okay, so normally what I do at this stage is I want to separate out the contents. So I'm going to show you where I'm getting this, and I'll try to remember to turn the browser off after I do. But if we do Golang strings, so what I want to do is take the whole file contents and split it up into parts. And in the strings code, there is a split. So you can take one bigger string and split it. And what you get back is a slice of strings. So what I'm going to do is I'm going to say fruits equals strings.split. I want to split the file data, and I want to split it on all the line breaks. So what should happen is that I'll get apple, and then it will split at the line break after apple in the file, and then give me the next word, and then split on the next word. And then I'm going to use a quick range loop. To show that they all number %d, %s, so the I and the fruit. So anyway, I'm going to use the split function to take the original file data and pull the parts all separately from each other. Oh, did I do it again? I did. I'm just going to keep forgetting that. Sorry. Okay, anyway, so where we're at is we've got the full file data all at once, but what we want is to split that large piece of file data into its individual pieces. And so the way we're going to do that is we're going to split the file data around the new line characters. So what you end up with is a slice of strings where each element is the piece of data before new lines and after new lines. Then I'm going to range over fruits, pulling out the indexes and the individual fruit names as I go, and print out the indexes. So what I should get now is they're all separate pieces. What? Oh, okay. Are we really going to have to cheat that? I guess we are. We have to cheat this. We have to type coerce it. So that file data was in a funky format, so I had to coerce it into being a string. Let's see if it works. It got one extra blank because the last line of the file was blank. So I'll probably have to pay attention for that. The reason for that is because the input file has a blank line at the bottom of it, so I could just get rid of that. Oh, it put it back. Well, it's going to be there. I will take it off at some point. We can write logic to take it off. So anyway, I find it personally, I usually end up wanting to split the pieces apart from each other because each line of the file is usually like some different piece of information, so I split it up. is what I've done there. And then there's the one blank one at the end. We can do this. Let's take that blank one off. So I'm actually gonna just slice the slice to get that blank one off the back. So I hope that makes some kind of sense what we've done there. Yeah, Nate, give me a sec to finish this thought on the file thing, and I'll bring that other one back up. Do you want to do a file write, or is it the file read is the main thing that you wanted? Okay, so opening up the oh, that was in lecture notes. That's right here. Okay, so the that. So I hope I saved it. I did. Okay, so there's the select operation piece. Keep forgetting to check to make sure that I don't have the browser.
Oh, one thing to consider here, Nate, if you're doing it with menuing, this could look cool if you do this. Just to clear the screen right there, I think that could look cool. It'll make the output of the program, I think, look slightly prettier. You can experiment with it and see what you think. Okay, I'm gonna sign off here. My back's getting tired. I don't have the best chair for doing this. It's a lawn chair right now. So anyway, I need to sign off. You can always email me if you have questions. Um, I'll sit here and watch chat for just a little bit longer, make sure I don't leave anybody stranded. But otherwise, everybody have a good weekend, and I will be goodbye. And thank you for being here, and thanks for the help, and thanks for offering to help people and helping people. So that's really really terrific. I appreciate it. I will see all of you on Tuesday afternoon next week. So have a good weekend.